This video is a bit of a backstory to what I've been working on, or what I am working on currently. So about 2 years ago, I took my first computer science course in college, and we learned a lot about logic gates early on in the class. And I thought, you know what would be really cool? To try to recreate what I've learned in Minecraft. Now, at that time, I had heard of people making computers in Minecraft before, but I hadn't actually like looked up any. And so at that point, I decided I'm not going to look up any computers in Minecraft that other people have made. I'm only going to make my own and then like compare it afterwards. That way, I would be completely figuring out how to do everything on my own. Now, as it turns out, after I made kind of my first version of a computer in Minecraft, I would look up other videos, and most of the videos I found didn't really explain super well, or at least I didn't watch the parts where they explained how they did it because I still am working on mine. Um, but to start off, I worked through the different logic gates. And so in Redstone, in Minecraft, we have Redstone, which basically acts as a wire. So you can place a lever at one end, you can turn it on, and it sends a signal, and you can turn it off. And this actually only goes a certain distance, and then you have to put a repeater, which boosts the signal again after that, which also adds a delay, which is great for timing things, but it's also really bad for making electronics in Minecraft because it makes them incredibly slow, which you will see in a little bit. Then one of the other tools that we have is the redstone lamp, which also puts out a redstone signal. But one of the things that we can do with this is if you put a redstone lamp on a block and then you send power to the block, it turns it off. This turns out to actually be the simplest gate, well, the second simplest gate in Minecraft. So the first simplest gate that we have is what's called an OR gate. So a logic gate is basically just a comparison between one or two signals. So these are our two inputs in this case, and this is our output. So if one is on, it sends out a signal. If both are on, it sends out a signal. If the other one is on, it sends out a signal. The only time it doesn't is if they're both off. This is an OR gate. If this or both is on, then the result is on. The next simplest is known as the NOT gate. So this is a NOT gate. If this is on, this is not. If this is off, this is not. It basically just reverses whatever signal you give it. The next gate that you have is known as an AND gate. And the way that you can make that in Minecraft, if I can do it right from memory here, is something like this. Sometimes it ends up shaped a little differently in different places in my computer for space reasons, but this is like the clearest to see what's going on. So I'm actually going to put this here. This will be our output to make it nice and clear what's happening. So here are two signals. So because it's called an AND gate, you might be able to guess what it does if you don't know already. If both signals, it only comes on, or I should say the output is only on if this and this are both on. So just one of them, nothing. Just the other one, nothing. Neither one of them, nothing. But if we turn both on, this and this, the output is correct. Or the output is on, I mean. So this took a little bit of figuring out to do in Minecraft. Because at this point, I'm sure there are YouTube videos out there explaining this that already existed, but at this point, I have not looked at any because I don't want to, because I wanted to figure out all of this on my own. So with this knowledge of these logic gates, I then built my first Minecraft computer, which the definition of computer is kind of lax here with this because it's not necessarily a full real computer in the Turing complete modern kind of sense in the word, but it is a calculator, basically. So this is the display for our calculator. So I'll show it working first, and then I'll explain briefly how it works. So this is a display completely in binary. So if you don't know binary, that's fine. I'll just say what each number is. So here's 1, and here you can see it is incredibly slow. We can make this that's 3 if it ever comes on. Make 5, all the way up to 255, which is if you turn every single one of these on. This, by the way, these levers, this is a binary number. So I'll probably make another video actually using Minecraft to explain binary at some point, but this is a binary number. So you can picture these as ones and zeros. So this is a 1, this is a 0. On is 1, off is 0, which is how actual computers work. That's why binary is used, is because computers are just using circuits that are either on or off. So all numbers are either ones or zeros. So here we can add, this is the second number. So these are the two numbers that you would add, and this makes it so that if it's off, you're adding, if it's on, you're subtracting. So it has to kind of reset after you click subtraction. So if we do, let's say 3 plus 1, this is 3, this is 1, well, we should get 4, which will just be 1 light. Yep, that is correct. And if we do, I guess I could have just done this. If we do 3 minus 1, we should get 2, which will be this light. It takes a very long time to process. But there is our answer. And this extra bit that's over here, that is kind of an overflow bit. So if you add two numbers, if you add 128 and 128, basically the 1 gets carried 1 digit over. So there are 8 bits here, which is known as a byte in computer science. So 1, 2, 3, 4, 5, 6, 7, 8. But this 9th one that overflows into a second byte, that happens if you add 128 and 128. It's like if you add 1 to 99, or you add 50 and 50, you get a third digit. But in this case, we're getting this digit. So this is the behind the scenes of how all of this works. The chaos of all of this is just getting all of the signals from each of these levers to the places that they need to be, and getting the signals of all the results to these pistons where they need to be. So something I did not think through at all when I made this first computer was efficiency. So everything is very spread out, which means it needed a lot of repeaters to boost the signal, which makes it incredibly slow. But it does work. So here you see this adds 1 bit. So this is 1 digit. And then it carries over to adding the next digit, which is this. And I won't get completely into the details of that, but you can see all of this is made from those logic gates. Here's an AND gate, here's an AND gate, here's a NOT gate. Actually, as it turns out in Minecraft, the AND gate is made from 3 NOT gates. I could not think of an easier way on my own to do that. Maybe somebody else has thought of an easier way, but basically that's how the computer works. It's just a lot of logic gates all connected. And there are actually 2 layers. So when I made this, light blocks were not added to the game, so this is very dark. But this is exactly the same thing as the top. And the bottom part computes the first 4 digits, and the top part computes the last 4 digits. So when it gets done then with all of the processing, all of these signals, all of the outputs of each of these parts come all the way back here and connect to these pistons. And it was one of the trickiest parts of this was actually not just getting all the logic gates, but or getting all of that figured out, but the hardest part I think of all of this was actually getting all of these redstone signals to fit together without interfering with each other, because redstone likes to connect. So like if you remove this, these connect to each other, which is not what we want. So there's a lot of like logistics of that sort of stuff that took forever. But maybe not nearly as long as this computing. I like to let it just reset its mode. When you switch it from addition to subtraction, it does that. It's just a byproduct of how it's made. And it looks cool. So that's it for this video, but I did make a more efficient version of this computer, which is linked at the end of this video if you would like to watch that. It removes a lot of the excess space and makes it compute much faster than this.